Good evening, Titans. This is Mr. Sturts. We are now on lesson 7.8, which deals with factoring polynomials completely. So grab your student journal or wherever you take your notes and let's get going. Our core concept today is factor by grouping. Now this is a little different type of grouping that we're going to use, especially when we have four terms in our polynomial. By grouping, it's just kind of how it sounds. We're going to group two sets of parentheses together where we can factor a GCF out of that set of parentheses. We also have factored completely, and we'll get into that as we get down the line here. But go ahead and write down those two vocabulary words in your notes, and we'll do a couple examples here. Okay, our first one here, it says factor each polynomial by grouping. Notice we have four terms this time instead of three. So we're always going to use our factor by grouping method. Okay, and really what we're going to do is we need to group two terms together that have a GCF. Okay, and it's addition, so we can rearrange things if we need to. But on A right here, we can already go ahead and see that these first two terms, if we put parentheses around those, we can factor out an x squared out of that first term, out of that first set of parentheses. So let's go ahead and, if we factor out an x squared, we're going to have just 1x left plus 3. Okay, now we look at our second set of parentheses. Keep our addition in there. What can we factor out of there? Well, we see we can factor a 2 out of both of those. So let's go ahead and do that. And again, we have an x plus 3 left in our parentheses. Okay, now we see that in each set of parentheses we have the same exact thing. So really what we're going to actually do is almost factor that out again. So whatever in parentheses we're going to write out front, keep it in parentheses. Whatever we have left over now, if we factored out that x plus 3 out of both of those terms there, what we have left is an x squared, okay, because we factored out this x plus 3, it's gone, plus 2, okay, because we factored that x plus 3, we pulled it out front. Now what we have left is our two sets there multiplied together. This is our factored form here, and that's our final answer. We can't factor x squared plus 2 any further, so we're done. Okay, let's try example B here. Let me clear this. Okay, now we look at those first two terms, x squared and y. We can't factor anything out of that, so what we really need to do is rearrange it. It's an addition problem, so we know we can do that. Let's just go ahead and let's flip this x and y. Okay, so if we rewrite it, we have x squared plus x. We know we can factor an x out of those, plus our other two terms. If we have y plus xy, we know we can factor a y out of there. Okay, so let's go ahead and start factoring here. If we take an x out, we have an x plus 1 left. Plus, if we take a y out, we have a 1 plus x left. Okay, we've factored each two terms out now. In parentheses, they're not exactly the same, but remember, addition is commutative. We can switch things around. Okay, so really we have x plus 1 in our parentheses. That's what we're looking for with grouping. And we're done. If we rewrite that, if we pull that x plus 1 out front, what we have left over is our x plus y, and we have our factored form, and we're finished. Okay, that's really, in general, that's how we factor by grouping. Alright, let's do a couple more here. If we look, we know we can factor an a squared out of those first two terms, but if we look at the last two terms, we can't factor anything out of the a and the 3. So let's go ahead and flip these two around and factor by grouping. So if we rewrite again, we have a to the third plus a in parentheses. We know we can factor an a out of there. And in our other set, we have a 3a squared plus 3. We know we can factor a 3 out of there. Hopefully what we get left over in the parentheses is the same thing. Let's check it out. If we factor an a out, we have an a squared plus 1 left in that set. Plus, if we factor a 3 out, we have an a squared left. Plus 3 goes into 3 one time, so we just have plus 1 left. And again, we have our parentheses equaling the same thing. That's good, that's perfect. So our answer in parentheses here, a squared plus 1. And if we factor those two things out, all we have left is an a plus 3. And that's in factored form. We can't factor anything else. That a squared, if it was a minus 1, it would be a difference of squares, but since it's plus, we know we're done right there. Okay, let's go ahead and try number 2 here. Again, we look to factor. If we leave those terms the way they are, we know we really can't factor anything out of a y squared and a 2. So let's go ahead and rearrange again maybe let's just move let's switch these two here. If we do that, we're going to have a y squared plus 2y in parentheses plus, what do we have left over here? We have a 2x plus yx. Okay, if we look at those two sets, we know we can factor here. We can factor a y out, which we have y plus 2 left over. Plus, we see we can factor an x out of that second set. So we have a 2 plus y left over. Again, addition, commutative, we can switch things around. This is what we're looking for. Perfect. If we take the y plus 2 out front, we have a y plus x left over. Can't factor those any further, and we're done. Okay, that's factor by grouping. We're switching things around. Okay, now we do have 3 terms here. We do have a trinomial. Let's go ahead. We can still factor this. Looks like we could use grouping, but really we don't need to. What we're going to do here is factor out. We see a 3 can come out of each of those, so we'll factor a 3 out. And we also see we can take an x out. Okay. If we factor those out, let's see what we have left over. We have an x squared plus 3 goes into 6 twice, and we still have an x left, so 2x minus, if we take 3 goes into 18 6 times, and this is what we have left here. Now we look to factor. Can we factor x squared plus 2x minus 6? If we try our x method, we have a negative 6 up top and a 2 on bottom. We need to multiply to get to a negative 6 and add to a 2. I'm just going to help you out. We actually can't factor that any further. This is unfactorable, that x squared plus 2x minus 6, so this is actually our final answer here. Okay, let's go ahead and do part B now. We know we can factor a 7 out of both of those. Let's also take an x squared out. If we do that, we have an x squared left minus 7 goes into 28 4 times. Now let's check and see if we can factor here. Can we factor x squared minus 4? If we think back to last section, it's a difference of 2 perfect squares. So what we do is let's go ahead and use our shortcut, our little pattern. We know that the square root of x squared is x. Square root of 4 is 2. Since it's a difference of squares, we're going to write it twice. One is positive, one is negative. And we have our answer. Now it's factored completely. We had to keep checking. We could factor one more step, and we're finished. Okay, last couple examples here. Now we have equals 10x. Really what we want, if we remember back to last section, we want everything on one side of the equation. So let's go ahead and subtract our 10x over. And if we do that, we're left with 2x to the third plus 8x squared minus 10x. And don't forget equals 0. That's very important. We have to have that right side equal to 0. Now we look to factor. Can we factor anything out of 2x to the third plus 8x squared minus 10x? We know a 2 goes into each of those. And each term has an x, so let's go ahead and factor out a 2x. Okay, what that leaves us with is an x squared plus 4x minus 5 equals 0. Don't forget that equals 0. Now let's go ahead. Our leading coefficient is 1, so we can just use our x method. We put our negative 5 up top. We put our 4 on the bottom. What multiplies to negative 5 adds to 4. We can use a 5 and a negative 1. So what we have in our answer here is we have 2x. If we continue, we have x plus 5 and x minus 1, all equal to 0. Now we need to set each one of these equal to 0 and solve. We have 2x equals 0. We have x plus 5 equals 0. We have x minus 1 equals 0. Using our zero product property, we have to solve for x on all of these. So we see on this first one, x is going to equal 0, x is going to equal negative 5, and x is going to equal 1. Okay, we actually have 3 separate answers there. Okay, last example here. Let's go ahead and factor out an x. We're left with an x squared minus 25. Okay, equals 0. Now again, we see difference of squares. We see 2 perfect squares, so if we go ahead and factor that, we're going to have x plus 5 and x minus 5 equaling 0. Zero product property, set them all equal to 0. In the end, we get x equals 0, x equals -5, and x equals +5. So 3 answers there again. Okay, we just need to, on this, we can actually factor one more step. Okay, we said usually when we factor once, we're done. Well, in this section, we got to check if we can keep factoring. A lot of times we're going to end up with perfect squares, or we're going to end up with difference of squares, or perfect square trinomials. Okay, now that we're finished with the notes, go ahead and open up to page 212 in your student journals. Go ahead and complete numbers 2, 5, 9, and 18. We will check these tomorrow in class. Thanks for watching.